Alright, multiplying polynomials. Now we're going to multiply these together. Now the first one, I'm going to admit, it's actually not polynomials. That's a monomial times a monomial, just to kind of get us started. So remember, those parentheses mean that we're actually multiplying those together. So you're going to go ahead and multiply the numbers together. This is just like when we did exponents. You guys have done this. 2 times 4 is 8. And then remember, we would do, when you multiply x times x squared, that's when you would add the exponents. Remember that? Before we had like x squared times x to the third, and we would get x to the fifth. We add those. So we're adding this 1 plus 2 to get x to the third. So you get 8x to the third on that one. Okay, let's make one a little bit more complicated. So same thing here. You might think of distributive property when you see this parentheses and a number in front. So what I'm going to do is I'm going to take this 3x squared times everything inside my parentheses. So this is a trinomial, has 3 terms. Multiply all these times this. So I'm going to take 3 times 5 to get 15. X squared times x squared. 2 plus 2 is 4. And now I'm going to take this times my next number here. Negative 3 times 3 is negative 9. And x squared times x is x to the third, because you add this 1 plus 2. And then finally, I take it times 1. So 3 times 1 is 3. And there's no x here, so that x stays as x squared. It doesn't change. It just stays as x squared, since there's not an x to change the exponent. Notice they're all unlike terms. If you have any like terms, we would add them. But they're all unlike terms since the exponent is different. So we are finished with that one. Alright, so those problems weren't really new. This is what's new. Is you've never had a problem where you had to multiply 2 terms by 2 terms or more. Because this is no longer just distributive property. You have to multiply both of these by both of these. There's actually about 5 different ways to do this. I am going to teach you only one method called the box method. Because when we get to factoring, the box method is by far the easiest and best method for factoring. And in order to do that for factoring, we have to know how to do the box method when we multiply. Alright. So when we have 2 by 2, I'm going to make a 2 by 2 box. I'll show you what I mean. So in this square, I make a 2 by 2 box. This first term goes up here, and then this is a plus 2. Remember, the plus goes with the 2 there. On the side, I put this term x, and then this minus 3, I'm going to make a negative 3 right there. So they go on the top, and then on this left side of our box. Now what we do is we fill in the box. So I fill in this square here by multiplying what's above it by what's to the side of it here. So to fill this box in, I take x times x, and that's x squared. Alright? And then this box here, I take what's above it, the 2, times what's in front, x. So I take 2 times x is 2x. And now down here, this box, I take what's in front of it, negative 3, times what's above it, x. Negative 3 times x, negative 3x. And this last box, what's above it is 2 times what's in front, negative 3. 2 times negative 3 is negative 6. So I multiplied both of these by both of these to get my 4 answers. Now, do you see any like terms in there? Notice the like terms are diagonal right here. We can actually add those together. You take this cross in the box and I make it a plus sign, and I'm going to put it equals out here in the corner. Negative 3 plus 2x is negative 1x. So these I'm combining like terms to get my answer here. And guys, this is the answer. This is how you do it. So you have x squared. I got this answer. These both added up to negative 1x, and then minus 6. So when you multiply these two binomials, this would be your answer. That's how we use the box method. So let's do a few more examples. I have a 2 by 2, so I draw my 2 by 2 box. I probably should have drawn it bigger. Oh well. Okay, this first x goes on top. Negative 1 goes right next to it on top. This x goes to the side, and then negative 3 goes to the side. Now to fill it in, I multiply x times x for this box here to get x squared. This box, I take what's on top, negative 1 times what's in front, x, to get negative 1x. This box, I take the x times this negative 3 in front of it to get negative 3x. And this box, negative 1 times 3. You see how I'm taking what's on top and what's to the side. And this is the answer. When I combine negative 1 times negative 3, it gets positive 3. Do you see like terms in there? Notice they're diagonal. Guess what? They will always be diagonal. Negative 3, we make this a plus sign, plus negative 1 is negative 4x. Combine those like terms, bring it out here to the side, and our answer, x squared minus 4x, that's a positive 3, so put plus 3. There we go. Okay, I have another 2 by 2, so I did a 2 by 2 box. So we have 3x plus 4, so that's a positive 4. X plus 5, positive 5. And multiply these together. So this time it has a number, 3, and there's not a number here, so it's going to stay 3. X times x is x squared. This box, 4 times x is 4x. This box, 5 times 3x. So we take 5 times 3 to get 15. This doesn't have an x, but this does, so don't forget to put the x on there. It just stays a normal x. 4 times 5 is 20. Notice our like terms are diagonal, so let's add those together. 15 plus 4, I always put an equal sign here. 15 plus 4 is 19, so we get 19x. So our answer is 3x squared plus 19x plus 20. There we go. Sometimes you have a problem that looks like this, x plus 5 to this, and it's squared like that. And so it's a little confusing at first. But remember, squared just means you take this x plus 5 and it's multiplied times itself. So just another way to write two binomials that are exactly the same. So we can set up our 2 by 2 box and write this along the top and the other one along the side. X times x is x squared. 5 times x is 5x. 5 times x. In this box, remember you're multiplying 5 times 5. Sometimes I see like 10 there, but 5 times 5, 25. Don't add, you're multiplying. Okay, my like terms, add these together. This is when we're adding 5 plus 5 equals 10x. And when you're adding, the exponent doesn't change. Alright, this is always x squared. This one's just an x. So we get x squared plus 10x plus 25. This one, and then this one, and then this one. Notice they're always in that order too. They're usually in the correct order. Okay, if you want to copy this down and try it yourself, pause the video and do that. But I warn you, this one, there's a little tricky thing that happens. Okay, 2 by 2. Remember this negative, the minus sign goes with the 4, making it negative. This is a positive 4. You're multiplying 3 times 3 is 9. X times x is x squared. 3 times negative 4 is negative 12, and then the x. 3 times 4 is 12, and then x. 4 times negative 4 is negative 16. So here's the interesting part here. Add like terms, and 12 plus negative 12 is 0. Those actually cancel out, which can happen, and that's fine. So really here we end up with only two terms, 9x squared minus 16. That one is a kind of a special thing where these cancel out. And you're left with this as your answer. So here's when that is different. It's not a 2 by 2. We have 2 by 3. So we need to make a 2 by 3 box. So I'm going to go 2 across and 3 down. And the order doesn't matter. You could go 3 across and 2 down, and it's fine. It won't make a difference. Alright, so 2 across because I have x minus 2, so x and negative 2 go there. And then negative x squared is in front of this first row, 3x in the second row, and 5 here. Positives I usually don't write the plus sign, but the negatives we have to have that minus sign. Okay, everything else is the same, where we're going to multiply to get the inside of the box. So negative, you can treat these as ones. Negative 1 times 1 is negative 1 still, and x squared times x is x to the third. Okay, so this box, negative 1x squared times negative 2. So negative 2 times negative 1 is positive 2 x squared. So this box, we're taking 3 times 1 is 3, x times x is x squared. This box, 3 times negative 2 is negative 6, and x, no x. 5 times 1x is 5x. And then our last box, like always, is just a number. 5 times negative 2 is negative 10. Okay, take a look. Do you see like terms? Notice where they are. They're diagonal again. X squared and x squared are like terms. Add those together. 3 plus 2, 5x squared. And here we have another set. Add these together. 5 plus negative 6 is negative 1x. That's pretty cool how that works out. So we have negative 1 x to the third, and these added up to be plus 5x squared, and these added up to be negative 1x, and then we have minus 10. I'm just going to rewrite it without the ones. So notice we have 4 terms now, the way we had our boxes. They're all unlike terms, so I am done, and this would be the answer. So kind of cool how it worked out the same way. What if you only have 1 and 3? Well, make a 1 by 3. I'm going to do this actually sideways this time. So 1 row and 3 columns. So the 1 term goes in front, and then these 3 can go on top. So you can still use the box method for this if you want. You don't have to use the box method if you want to just distribute. We can multiply these together. And do you see any like terms? There are no like terms this time. So then write your answer out like that. There we go. Okay, I want you to set up this box and try to solve it. Go ahead. Pause the video. Okay, now check. Did you set up your box this way? You can have it go in the other direction too, and 2x and negative 3 on the side, and this across the top. Check it. Okay, check your math. I multiplied everything. Did you get the same numbers in your box? Look for like terms and combine them. Here's what you get when you combine like terms. Watch out with those negatives. So your answer. These are all unlike terms. Oops, that's a 12. There it is. If you got this, you are doing awesome.